Good morning class. Welcome to the online classes for physics for class 10th. We have already seen that we have started the revision for the chapter that is electric current. In that we have seen that what was the electric current, what are the devices and the unit. We have seen what the potential is, what is Ohm's law and how he defined a resistance. We have seen the connection of resistance in series and the parallels and even the numerical related to that. We will solve more numericals in the live class too. But now we have to see the next topic, that is the heating effect of current. Like current have the different effects. Like when we use that current for different other purposes, like for the heat, for producing the heat, for generating magnetic effect. Like different effects are there for the current. It can generate the energy, it can generate heat energy, it can generate a chemical energy also, it can give you magnetic effect also. So in the next class, maybe in your next chapter, that is the magnetic effect of current, is also a different kind of effect of the current itself. By the moving charge we can produce the magnetic effect, that means the magnetic field, and from a moving charge we can even find a heating effect also. So today we are going to see that what the heating effect of current means. So we know that whenever we create any kind of circuit, then we have a potential, means we have to give a potential so that the charge can move. So the number of the charges present on that layer, if it have to be moved, then we have to create some potential or we have to give some energy to it so that it can move from its place. So the work done required to move a single charge from its any kind of infinity point or from some particular distance to a required point, then that was considered as a potential, that is W upon Q, that work done required to move a single charge. So potential is always required in a circuit so that it can make the charge to move from its place. And we know that resistance is something which offers a opposing nature to the current. So whenever we have to decrease the value of the current or something so that the current can be opposed, so we have to connect a resistance of some derived ohm, that whatever we need in that circuit. And for the current we know that any metallic piece, if we have, that the number of the charges kept in that can move due to this potential what we are applying through the battery. So the battery will provide a potential to it so that the charge can move, and whatever the potential of that battery will be, like it may be 5 volt or it may be 8 volt, so that volt battery will try to make the charges to move, and as the charges move they will induce the current. But when we we have a metallic which have a resistance high, because it doesn't mean that everywhere we will be using a resistance wire, but any kind of metal which have a high resistivity, means they can oppose the current totally and the flow of the current will be less, means they are less conducting and resistivity will be high, that means they will be having the high resistance. So the materials which will be having the high resistance, if they are connected in the circuit, then what will happen, that the current flow will be less, but there will be a current, since they are inversely proportional, there will be some value of the current in the circuit, but the resistance will be high. And what we know, that as the resistance increase, means when the current flows through any circuit or any resistor, then whatever the energy loss is being done through that resistor, it will convert that heat loss of energy in the form of heat itself, means the energy dissipated by the circuit will be in the form of a heat energy itself. So what we can say, whenever resistance gets the current, or a substance or a metal which have a high resistivity, they will be having the less conductivity, means the motion of the charges will be less. But as the resistance is high, when you increase the value of the potential, so the current will also increase, but since the body's resistivity is high, so the number of the charges moving will also be less, but the resistance will increase. As the resistance will increase, the current will be decreasing. So now the object is having a high resistance, since it is of high resistivity. So as the resistance increases, we can say that the energy loss in this resistance is will be in the form of the heat energy. There will be a loss of heat, like you have seen in the friction. Like whenever the friction increases, means the rubbing of the surfaces increases, what will happen, that the heat loss will be there, means the body can get heat up. So this is what the form of a loss of a heat. Here also, if you increase the potential or increase the current flow in a circuit, then what will happen, the resistance will increase along with that potential, because V is directly proportional to R. but V is directly proportional to current also. So when you are applying the potential, the current will increase and the resistance will also increase. But resistance and current are inversely proportional. What that means, that if in a circuit you are using a metallic piece, then its conductivity is more. There what will happen, that according to the potential, its charges will be moving fast so that the current can be induced more. That means they will be having the high conductivity, but the resistance will be very low. Now, if we are using a metallic piece which is having a high resistivity, some materials used to have a high resistance, doesn't mean that it will be in the metal itself or in the periodic table itself. So, what will happen, that these resistivity high substance will get very much resistant, and due to which the current will be less, and the particle which, or a substance which is getting more resistance, it will lose its energy in the form of a heat. So what will happen, that when you apply the potential, the resistance will also be increasing along with the potential, and due to which the heat is being released from the object. So this effect through which when we apply a potential and the current used to be induced in the circuit, then the substance due to its high resistivity will lose their energy in the form of heat. So this effect of giving a heat from the electrical circuit, this heat energy of, means what we can say, that the electrical energy is almost converted into the heat energy. So the dissipation will be in the form of the heat. So this is the heating effect of current, that is of conversion of electrical energy into the heat energy in the simple words. But we know that as the potential increases, the the resistance also increases, and as the resistance increases, it will lose its energy in the form of a heat. That is what the heating effect of current is. Now, first time this heating effect was observed by a Joule. So we know that Joule was given a rule for a work done also, he has given for the heat also, means in the form of energy itself he told a lots of laws, like you know that even the work done was given by the unit joule, even the heat was given by the joule, even energy is given by the unit joule, because Joule was a scientist who gave normally lots of information about the energies and the work done. So this is also a form of energy. So what we know, that Joule is only have told us about this heating effect of the current. So we know that as the current produces a heat, since it's a heating effect of current, so we know that this effect can also be useful for us, because heat, if it is giving, we know that any like some specific kind of substances have high resistivity, so they will be giving the heat a lot, so we cannot use in the electrical appliances at our home, but we can make that advantage of that heat effect of the current. That means if we require any heat of the object, then we can use that object in the form of a advantage, we can say that, or we can use make a application of it, so that we can use in our electrical appliances, so where we need the heat. Now the Joule have observed that whatever the heat that is being dissipated by the resistive substance, there this heat given by the substance is directly proportional to the current whatever we are applying, and we know as the current totally increases in an object, then only the resistive substance will get the high resistance, due to which the heat will increase, and we know it will be directly proportional to resistance also, because whatever the resistance we will be providing to the circuit and whatever the resistivity of the substance will be, as the resistance is high, the heat dissipation will be also high, so the electrical energy will be totally converted into the heat energy. So this heating effect of current is directly proportional to the I square. It is given as I square. Why? Because we know that I, how much it will be increasing, that much only the heat will be increased, but extra current is required. Why? As resistance is 5 ohm, then you will be giving 5 joules of heat, but current should be more than that, because resistance and current are inversely proportional to each other. So that is I square. And we know what the Joules law is, that is the heat. He gave a law that whatever the work done, means whatever the work done is equal to that of the time, whatever the current flowing in the particular time, that is what the current work done in the circuit will be. Like electric potential, we know that the work done required to move a charge, but here what we will be saying, that work done required to move a charge from a particular distance is different from electric potential. But now if we talk about the Joules law, we know that the work done required to move the charge and have to get the current, then it will be Work done equals to V into I into T, means along with the time of the flow of the current and by giving the potential to the circuit, we can increase the work done. So in the absence of any other external effect, this energy will be almost be dissipated in the form of the heat itself. So the amount of heat produced will be what it will be equal to that of the potential what you have given, whatever the current you have applied and what the time is, because as much the time will be taken, that much the current will be flow and that much resistance will also be occur in the substance. As the resistivity is high, so that much heat energy will also be dissipated from the circuit. So that is what H is equals to VIT. But from the relation of the Ohm's law, we know that I is equals to V by R and V is equals to IR. So on putting the value of V is equals to IR, we will be getting I square RT. So this is what the relation which was verified by the Joule, and he gave this law so that the name was given as Joules law of heating, because that was the heating effect of current is different, that any resistive substance, if you are providing any potential and the current is applied, then it will be giving the loss of energy in the form of a heat. That is what the heating effect of current is. But Joule have derived it mathematically, that if we give the current in the form of I square and if we provide the resistance to the circuit, and with the according to the time of the flow of the current, the resistance will also increase, and as the resistance increase, the energy loss will be in the form of heat, and as much the heat will be given out from the circuit, we have to make it as an application and we have to use it so that it can be used in our daily life also. So what is the Joules law? If it come as a question, then what you can write, the Joules law is something that the heat developed by the electric circuit and the flow of any of the current, it will depend on the square of the current, that means it will be directly proportional to the square of the current. It will depend on the resistance of the circuit, that it will be directly proportional to the resistance of the circuit. It will depend on the time of the flow of the current, that means it will be directly proportional to the time. So what it is directly proportional to I square R and T. So H can be written as I square RT. That is what the Joules law is. Here you can see one question, that is find the heat energy produced in a resistance of 10 ohm. So it is given what the heat will be there produced in a resistance of 10 ohm when 5 ampere current flows through it for 5 minutes, means it is given that the time is of 5 minutes. So till 5 minutes you will be applying the current, and that current flows in the circuit which have the resistance of 10 ohm. So we know that Joule in that time should be in seconds. So here it is given as 5 minutes, so we will convert it into seconds, that is 5 into 60, it will be 300 seconds. So H is equals to I square RT. So it will be I is given as 5 amperes, it will be 5 square. R it is given as 10 ohm, it will be 10, and T that is 5 minutes, and to change it into seconds we can write it as 300 seconds. So on multiplying 300 into 10 into 25, we can get 75,000 joules. So what is the heat energy is given by this 10 ohm resistor when the current flow is 5 ampere, then it will be 75,000 kilojoules. Means 75,000 joule it is, but the 1000, we know 1000 is given as 1 K, so it will be 75 kilojoule, that is 1 kJ, that is 75 kilojoules is when the heat energy produced in the resistance of 10 ohm when the current flows for 5 minutes of 5 ampere. Okay. So this is what the advantages we are using the heating effect, because heating effect means the loss of the energy in the form of a heat, but that heat can become a disadvantage for the appliances. So we have to make it as an application for our electrical appliances. So we need we have to make our water to be get heat. We know to iron up the dresses we have to require some heat, or to get your any cooking process, any of kind of cooking, we need the heat. So there induction stove also is there also the heating effect of current has been used. Geyser which we are using nowadays in the winter season, that is also the heating effect of current. Even the hair dryers that used to give the hot air outside so that our hairs can get dry up, that is also an electric appliance which are using the heating effect of current. Electric fuses are also there, electric heaters are there, induction stoves are there, electrical that kettle in which the tea is being prepared. So room heaters are there, toasters. So different appliances are there which use this heating effect of the current. But the substance which has to be used in this type of electrical heaters or any kind of devices which uses the heating effect of current, that should be have a high resistivity. That means conductivity will be less, but the resistance should be very high so that they can get more resistance, due to which the heat energy loss will be high. So some of the applications you can see the electric iron and the electric heaters. But remember that in the electrical appliances like iron, it is the element which is used as nichrome. So heating elements are mostly made of the nichrome, but in iron, remember it is nichrome. An alloy of nickel, chromiums are also used, but remember in iron it is nichrome. And for the 12-volt bulbs, you may have seen that mirror glass bulbs are used to be used in the earlier time. So that 12-volt bulb, 12-watt bulb it is. So in that bulb a small wires used to be there, and when it get fused it used to break and that wire comes out, and from that we used to recognize that yes, the bulb got fused. And in that bulb, that wire is made up of a tungsten element. And what the tungsten element is, when it get totally heat up due to this current, means when you give the heat, that wire, means that tungsten element get heat up, and since its resistance is very high, means its resistivity is high, so what it used to, it gives the heat energy, means it releases the energy in the form of a heat. So as the heat comes out, so it, in that heat the electrons used to flow, due to which the light glows up. So in that tungsten element is being used, in iron nichrome element is being used, chromium so it's been used. So this kind of iron rods are also being used in our homes or to heat up the water. So this different ionic, means thermionic emissions used to be done, like by heat the electrons used to get emitted, due to which the current used to be induced. Or we can say that the heating effect of other current, like using that resistive object, we can get the highest temperature, and that we can make the dress up iron, or we can make our cooking utensils to be get heat up, or to make our milk to be heat, or the water to be different applications we can make. Means we have to make that heating effect as an advantage, so we are using different elements to make it as an advantages. Okay, so this is what the heating effect of current is. This is one of the topic from your electric current chapter, and the next one we will think about the power and electrical consumptions. Okay, so next we will be seeing the further classes. So thank you class.